For question number 9 in section 3.3, zeros of polynomial functions, we're asked to factor the function into linear factors given that k is a zero of f of x. Our function f of x is equal to x to the fourth plus 3x cubed minus 42x squared minus 172x minus 168, and we're given that k equals negative 2 with a multiplicity of 2. What that means is that negative 2 is a zero of the polynomial function. That means x plus 2 is a factor, not once, but twice. So x plus 2 and x plus 2 is a factor of this polynomial function. Another way to write that would be x plus 2, that quantity squared. So when we set up this problem with synthetic division, we're going to put a negative 2 in the box and list the coefficients of the polynomial function. 1, 3, negative 42, negative 172, and negative 168. The first coefficient, bring down 1 times negative 2 is negative 2, 3 and negative 2 is positive 1. 1 times negative 2 is negative 2. Negative 42 minus 2 is negative 44. Negative 44 times negative 2 is positive 88. Negative 172 plus 88 is negative 84. Negative 84 times negative 2 is 168. So we do end up with a remainder of 0. And that's going to allow us to simplify what's below the line even further. If we know net k equals negative 2 is a 0 with a multiplicity of 2, we're going to do synthetic division again with just what's left underneath here. And I'm going to set it up like this with a negative 2 here, and I'm going to use synthetic division in this way. Bring down the 1. 1 times negative 2 is negative 2. 1 and negative 2 gives you negative 1. Negative 1 times negative 2 is positive 2. Negative 44 and a positive 2 is negative 42. Negative 42 times negative 2 is positive 84, and we get another remainder of 0. Now that happens because negative 2 is a 0 with multiplicity 2. So we do synthetic division twice each time, making it a simpler problem, reducing those powers. So what we have is what's left over. We had x to the fourth, and then this would be x to the third. So the result here is going to be your 1x to the second power minus x minus 42. We want to factor that even further. This is one of those, like in the review, when you factor x squared minus x minus 4, the factors of negative 42 that add up to negative 1 would be minus 7 and plus 6. Now we're going to use that as part of our answer, but we also know that this is part of the answer as well. So x minus 7 is a factor, x plus 6 is a factor, and x plus 2 quantity squared is a factor. Now it doesn't matter what order you put these factors in, as long as all of them are listed and they're multiplied together. So we have x minus 7, x plus 6 is a factor, x plus 2 quantity squared. It's a repeated factor. We say it has a multiplicity of 2. Okay, let's look at number 10. In number 10, we want to list all the possible rational zeros and find all the rational zeros and factor. So there's really 3 parts to this question. The way you find possible rational zeros is by taking possible rational zeros are always in the form of, could be a fraction, where the numerator of the fraction are factors of factors of the last term divided by factors of the leading coefficient. Okay, so what that is going to look like is we're going to look at all the factors of negative 21, and we're going to divide by all the factors of the leading coefficient, which is 1. So what are the factors of negative, I'm just going to put factors of negative 21 divided by factors of 1. Factors of negative 21 are positive 1 and negative 1, positive 3 and negative 3, positive 7 and negative 7, and positive 21 and negative 21. And the factors of the leading coefficient are all positive 1 or negative 1. So if you take each one of these and divide it by positive 1 or negative 1, the possible rational factors are plus or minus 1, 3, 7, and 21. So these are all the possible rational zeros. Now out of those, we want to choose which ones do give us the actual zeros. For the second part, we want to choose the rational zeros. Now this is a third degree polynomial, meaning that the greatest exponent is 3. That means you can have at most 3 rational zeros of this polynomial function, but we have actually listed plus or minus 1, 3, 7, and 21. We've actually listed 8 possibilities, but at most 3 of those are going to be zeros of the polynomial function. So to determine which ones are, we can use synthetic division and find all the ones that will give us a remainder of 0. We use, if we try positive 1 to begin with, and use the coefficients 1, negative 3, negative 25, and negative 21, and work through this until you find one that gives you a remainder of 0. So we plug in 1 with synthetic division, and we simplify this. We get something that doesn't end up with a remainder of 0. So positive 1 is not a 0. It was a possibility, but because we don't end up with a remainder of 0, we say it's not a 0. So let's try another one. Let's try a negative 1. Using the setup, okay, bring down the 1 times negative 1, negative 1, negative 4, that will be a positive 4, a negative 21, and a positive 21. In this case, we do get a remainder of 0. So negative 1 is, one of the zeros is a 0. And we want to keep going until we get 3 of them. We can check all of them. That's one approach. Or you can continue to factor. Now, the last part of this question is going to require us to factor, so we can continue here. Since negative 1 it ends up with a remainder of 0, that means that x plus 1 is a factor, and then the other polynomial is x squared minus 4x minus 21. You know what, I'm going to back up here just to go through. You can go through and check for the second choice. You can keep going through and find out which of them do give you a remainder of 0. Let me just back up, apologize for that. Alright, so the next one on our list that we can try is a positive 3, doing the synthetic division again, working through, you get negative 75, negative 96. Okay, this does not give you a remainder of 0, so we can say 3 is not a 0. You want to keep checking. You can try negative 3. Negative 3, doing this with synthetic division. You should try all of them until you get 3 total. You get negative 3, negative 6, 18, that's negative 7, 21. It gives you a remainder of 0. Okay, so we have negative 3 gives you a remainder of 0, so negative 3 is a 0. And you can go through the whole list, but we can try one more. Let's try a positive 7. Okay, if we try positive 7 with the setup for synthetic division, we work through this. Okay, so we can say 7 is also a 0 of the polynomial. Now, out of all of these, the ones that ended up with a remainder of 0 were the negative 1, the negative 3, and the positive 7. So that's going to be our choices. Choice A. Now for the last part of this, we're asked to choose the factored form. You have already found that the rational zeros are negative 1, negative 3, and 7. What you can do is with the synthetic division with negative 1, that's going to help you find the factors. When you do the setup here, you get okay. Now this you can factor. We know negative 1 is a 0. That means x plus 1 is a factor. What's left here can also be factored further. This was an x to the third, so we're going to write it as x squared minus 4x minus 21. And we're going to factor that even further. The factors of x squared minus 4x minus 21, well, we know we're going to have an x and an x. Find the factors of negative 21 that will add up to negative 4. So that's going to be x minus 7 as a factor and x plus 3 is a factor. Now those can be in any order, and it appears that in mine it's listed as x plus 1 as a factor, x plus 3, and x minus 7 as a factor.